Hello, everybody. This is Brian Greene. And this...
Faith Salie, everybody.
Oh, thank you very much. And this is Brian Greene's book in large print because time has ravaged my eyesight. And I first interviewed you, Brian, a few months after this book came out in May of 2020, which everyone can imagine was a very specific time. You were upstate, I think.
Yeah.
I was in an apartment on the Upper West Side. It was on Zoom. The notion of time during those early days, when people said lockdown, it was a very specific experience to talk about time then. Now, to return to this, it's the same book. It was interesting to see what I dog-eared, to see what moved me, in fact, to tears again. I took a whole bunch of new notes. And I love that we're having this discussion at the New York Historical Society because, I mean, not only is this book about the entire history of the universe and about when history will cease to exist, but also because history is arguably both a science and an art. And you characteristically make room, in this book especially, for mathematics and music, for Schrödinger and Shakespeare. And I mean, it's just a joy to turn to the index of this book because you'll find there's Higgs particle, there's Mick Jagger, there's Big Bang, Big Bounce, Big Crunch, Big Rip. There's Over the Rainbow, Poe, Sylvia Plath, and you spend a moment on cheesecake, which I think, and you
vegan cheesecake.
Vegan cheesecake, and you make it germane. So my goal is to get to the cheesecake tonight. So history is about stories, and in this book, your story kind of begins with what you call the romance of mathematics. What do you mean by that, or what did you mean by that?
Well, it's interesting. I grew up, 4 blocks from here, 81st Street. And at an early age, my dad, who was a composer, singer, musician, he didn't go to college. He had what he called an SPHD, Seward Park High School dropout.
So good.
But he loved ideas. And so he taught me the basics of arithmetic at a very young age. And then would set me these problems, like multiply this 30-digit number by this 30-digit number. And I would spend the weekends 4 blocks from here with large pieces of construction paper just multiplying these numbers out. And it just felt to me so compelling to do something that nobody had done before. Now, in those cases, it's because it wasn't interesting. Yeah.
You weren't trying to just get your dad's approbation. You loved it.
Yeah, totally. No, I just got pulled into this world of numbers. And it was kind of a romance of this mathematical language, which I feel strongly is one that we invent, that we don't discover, but this wondrous thing that we compose that allows us to go off into strange places of prime numbers and the Riemann zeta function. We all make these ideas up, but this world that we create is so rich and compelling.
Raise your hand if you're waiting for him to say Riemann zeta function. But in the book, you say that part of the romance, and this is relevant to this notion of thinking about our time, and how finite it is that mathematics is a journey toward insights so fundamental they will never change.
Yeah.
Mathematics is permanent?
The truths are, and to me that is a remarkable quality. It was really first emphasized to me, again, when I was quite young. I went to IS 44, which is like 3 blocks from here, and I exhausted the math curriculum relatively quickly. So one of the teachers there gave me a letter. I didn't know what it said at the time. He said, take this, go up to Columbia and find somebody to teach you. So together with my older sister, I was like a little tiny, just like this. So we'd like walk and we started knocking on doors, randomly handing this letter, and most would read it and hand it back. But in the math department, knocked on one door and gave it to a fellow, and he read it, and he said, sure, I'll teach you for free. We didn't have any money or anything. And so I would go 3 times a week, and he would take me on these mathematical journeys. And he was the one who really, when I started to get interested in physics, and I was asking him, like, why do you do math? Why is it your thing? And he said, I do math because once you prove a theorem, it stands forever. And it finally hit me. everything else is impermanent. But these deep truths that come from this language of mathematics, they do stand beyond the test of time. And so there is something deeply compelling to latch on to those qualities of the world that are immutable. And mathematics certainly are among those qualities.
And your grasp of mathematics and your participation in the way mathematics has pushed our understanding has led people like you to understand that the math tells us the universe is going to end, right?
Yeah, I mean, it is interesting. You develop a language initially to describe everyday objects and entities with precision. That's really where mathematics comes from. But then you can follow the math to begin to talk about things that we can't directly see or observe or test, and yet are relevant to our sense of who we are and how we fit into some grand picture. And certainly after Albert Einstein gave us the mathematics of the general theory of relativity, which is our understanding of gravity that's most relevant for how the universe evolves on the largest of scales, when you follow that mathematics forward in time, in essence allowing you to kind of turn a cosmic film toward the future, the frames in that cosmic film are not particularly happy if you go sufficiently far into the future.
That's a spoiler alert. But you don't pull punches. You kind of tell us that right away.
Yeah.
Right away.
Yeah.
And I kind of want to get the bad news part over with early in the evening. Let's get to some numbers. How old is the universe and how much time do we have left?
Yeah.
My birthday's on Friday, so I'm feeling urgency.
Yeah, so at least on human scales, it's a relatively calming story. So back to the Big Bang is about 13.8 billion years. And, that's an enormous time scale. It's so large that even that's hard to wrap your mind around what that really means. But just to give a sense, if you were to compress all of cosmic history from the beginning until today into a single calendar year, as Carl Sagan told us to do decades ago, then all of recorded history takes place in the last 10 seconds of that calendar year. So December 31st at 11:59 and 50 seconds is when we start to begin to record things that are happening in the human landscape. All the rest is the lead up to that particular moment. So that's from the beginning until today, which is enormous. But then if you go from today into the future, the timescales get even longer. And I could take us through those real quickly if that would be a relevant thing to do. But I don't want to step on your narrative, however you want to go here.
No, that's fine. I'm quite breathlessly concerned about how long humans are going to last.
Yeah, well, that is a much more difficult question to address. It's obviously an important one to all of us. But because humans are these complex combination of ingredients, I believe we're still fully governed by laws of physics, and we can pursue that further. But to make predictions about human behavior is more challenging than describing the behavior of the cosmos as a whole.
Right, because this is a very self-centered human question, right? Because we could kill ourselves off a planet anytime soon, and the universe isn't going to blink.
Yeah, and it likely will happen. But if you put that to the side, the fact that there's a significant chance that we will self-annihilate one way or another, putting that to the side, you can say, how long will the Earth be here, at least in principle? And so that's probably on the order of 5 billion or so more years. Because in about 5 billion years, the sun is going to swell to over 200 times its current size. It will certainly engulf Mercury and Venus. It may engulf the Earth. If it doesn't, it will certainly scorch Earth in a dramatic way. If the Earth should happen to survive that, then it will hang around for another 100 billion years when it will spiral in to the dead sun.
Math tells us all of this?
Yeah, that's the amazing thing. And systems like the sun and the Earth, although they seem complicated perhaps if you just sort of think about it casually, they're actually relatively simple. What is the sun? It's a spherical ball of gas. What is the Earth? It's a spherical ball of rock. We have these complex shapes with all these inner processes that define what it means to be human, but inside the sun, There's not all that much going on. Inside the Earth, not all that much going on from the standpoint of physics. That allows us to calculate the behavior of these macroscopic objects with significant confidence.
Is there a thing that is time if there is no consciousness to clock it, pun intended?
Yeah, I don't know. Could time itself simply be a product of human ingenuity, allowing us to organize our perceptions of the world around us? It could be that that's what time is. But if you think somewhat more fundamentally of time as the language that allows us to discuss change, right? That's what time really is. It allows us to say, things were like this then, and they're like this now, and so there was a development, and time is the dimension along which that development can take place. Now, certainly change happened before human beings were here, right? I mean, we have great confidence, again, the Big Bang yields ultimately galaxies and stars and planets. We understand in rough outline those processes. Things really did happen. And so it suggests strongly that there was a conception of time before we humans were here to recognize it, and presumably there will be a conception of time after we are gone.
Because things will unfold,
yes.
And we call that entropy, and we will get to that in a moment. I just I love all the little nuggets that one picks up reading this. I mean, it's hard to have a dinner party discussion of entropy to the extent you can, but I do love learning that the Big Bang, the idea of the Big Bang, wasn't it articulated by a Jesuit priest?
Yeah, it's true. I don't know how many people are familiar with the name Georges Lemaitre. I mean, just a clap. Do you know that name? It's pretty tepid. Everybody
They might
clap
be
just
French.
so I can get a sense. Yeah.
There we go.
Thank you.
Father George.
Yeah, so not zero, but it is a known name, and he was an unusual character because not only did he have a PhD in physics
From MIT,
but he was a Jesuit priest, and he deeply wanted to understand the big questions. And after Einstein wrote down the equations of the general theory of relativity, Lemaitre was the first to successfully apply them to the universe as a whole. Einstein had done a version of this earlier on, but Lemaitre is the one who really pushed this idea forward, and he came to the conclusion that the universe should be expanding. And if it's expanding, then if you sort of wind that film in reverse, everything gets smaller and smaller toward the past, suggesting that everything was compressed together into what he called the primeval atom, sort of an initial atom from which everything emerged going forward in time.
That is not in the Old Testament.
It depends how you interpret
Depends
the
how you
words.
interpret it, yeah. But it's so fascinating to me that it was a priest. And I'll let you have the glory. Will you tell everyone what Einstein said when he saw Lemaitre's calculation?
Yeah, so Lemaitre joins Einstein at the Solvay conference in Brussels in 1927 to alert the great master regarding what he had found using the great master's own equations. And Einstein just turned to him and said, "Your calculations are correct, but your physics is abominable." And what Einstein meant by that was you can't believe all mathematics is relevant to the world. You have to have an intuition regarding which math really tells us things that we should take seriously about reality, and which math might be good math, the calculations are correct, but belongs in a mathematics textbook, not as a guide to the way the universe actually works. Now, the reason Einstein knew that the calculations were correct is he'd already seen them about 5 years earlier by a Russian physicist named Alexander Friedmann, who kind of did the same calculation and showed it to Einstein. At that point, Einstein said, "Your calculations are incorrect." And he wrote a little criticism of the paper, sent it to the journal, but Friedmann stayed on Einstein and proved to Einstein that the calculations were correct. So Einstein changes his criticism to say, the calculations are fine, I don't think it's relevant to the world. But in the margin of the criticism, you can literally see that Einstein was saying, but this is irrelevant to anything that we would care. And then he nicely didn't include that in the criticism. He was a little bit, he rose above, it would sound like sour grapes at that point. But he clearly did not think that the universe is expanding.
At what point did he see the light?
Well, he saw the light when we saw the light. So Edwin Hubble, using the powerful telescope at Mount Wilson Observatory, saw the light from distant galaxies that he recognized by virtue of how the light was being stretched, that the galaxies are all rushing away. And as galaxies rush away, the light that they send toward us will get stretched outward. Red-shifted is the language that we use. And he found a pattern in the redshifts that the farther a galaxy is, the faster it was moving away, which is exactly what you'd expect from a universe that's expanding. And once that data was clear, Einstein pretty much agreed. But I have to give you a small footnote that we never say, but since it's a friendly, small group here.
It stays here.
You know, the fact of the matter is, although we tell that story, it's only partly correct. Certainly the data helped Einstein get over this notion that the universe was static, eternal, unchanging, which is his philosophical prejudice. But it was really Arthur Eddington, another famous physicist from that age. And not to go footnote on footnote, but he's the guy who, when a reporter said to him, how does it feel to be one of three people who understands the general theory of relativity, he thought pensively and said, I'm trying to think who the third person is. So Eddington, who clearly Einstein respected, you know, he understood the general theory of relativity well, showed Einstein that Einstein's view that the universe might be static and unchanging, that the math showed that that solution to his equations was itself unstable. If you breathe slightly in this universe, if you flick it slightly, it will either start expanding or contracting. And so once Einstein saw that the math was unstable, he said, aha, this is not a viable way of envisioning the universe, at least according to his own general theory of relativity. Bottom line, though, by 1931, Einstein is a convert. He realizes that space is expanding.
And while we're dealing with fun trivia you can share with friends, the Big Bang was coined almost just dismissively, right? On the BBC?
Yeah, absolutely. So there was an alternative theory that was being pursued. It's called the steady state cosmology. And one of the proponents of that theory was on BBC discussing it and sort of dismissively refers to this other idea of an expanding universe as it all begins in one Big Bang, you know? And people are like, oh, Big Bang. You know, catchy name.
It'll make a great sitcom someday. Yeah. And that was in 1949.
48, yeah.
Oh, 48, okay.
Yeah.
All right, so the two processes that are running the show are entropy and evolution. And of course, one degrades and creates disorder, and the other creates and builds. And you talk about how they must act as a pair. You call it the entropic two-step.
Yeah.
Tell us about that.
Yeah, so there really are these two dominant trends. You know, if we try to understand the evolution of the universe from the Big Bang until today and on to the future, you can get mired in details, and for certain questions that's really important to do. But if you can find overall patterns and tendencies, it gives you a better understanding of what's going on, at least from sort of a 30,000-foot level. And the two dominant processes are, number one, the rise in entropy. This is called the second law of thermodynamics. It was developed as far back as the 1800s. It's something that we're all familiar with. Order tends to degrade into disorder.
You've been to my apartment.
There you go,
yes.
Right? So you leave in the morning and maybe it's all straightened up. You come back at night. How often is it more order?
Yeah.
Right. So it's almost always the case that it goes from order to disorder. And it makes sense because there are so many ways for things to be disordered. The Legos could be here or there, the kitchen, bathroom, you know, everywhere. But there are very few ways for it to be ordered. So it's harder to be ordered than disordered. And when we use the language of entropy, entropy is a measure of how much disorder. That's all that it is. And the idea is that entropy tends to increase because it's easier for things to have higher entropy than lower entropy. And as much as that's true at your house, it's true in the cosmos. So we believe the Big Bang was a highly ordered beginning, still uncertain why that is. Who, what, or how made it ordered at the very beginning. We don't know the answer to that, but it began in that highly ordered state and has been going toward ever greater disorder. But then you can ask yourself, well, if it's going toward ever greater disorder, what about us? right? These objects
We're
were all
so
highly
amazing.
ordered,
Yeah.
right? And that's where this other process of evolution comes into the story, which has an interplay with this. Evolution has this wonderful capacity to build structures that are ever better adapted to their environment. Now, normally we talk about that when you learn it in high school at the level of living systems, right? That's, after all, how Darwin wrote it down. Living systems have progeny. Progeny generally can differ from their parents. Those distinct characteristics that make the progeny better able to survive are likely to persist because they will cause the being to survive and reproduce and thereby spread to future generations. Good. But there's a version of evolution by natural selection that's much more general than the way Darwin initially framed it. Molecules themselves can engage in a version of evolution by natural selection.
You call that chemical combat?
It's a kind of chemical combat, exactly, because if you have molecules, in some sense, battling against other molecules to gain raw materials, because once a molecule learns how to make a copy of itself, and this is something that molecules can do, like we know how DNA does, it's a molecule that makes a copy of itself. A molecule, if it can pull in raw materials and use its own structure as a template for making copies of itself, those molecules that can make more copies faster, swifter, with greater economy and stability, those molecules are going to win in the sense that they're going to dominate the molecular demographics. And if that molecule makes a copy that's not precisely the same, a mutation, progeny that differs from the parent, if the progeny is even better at making copies, then it will come to dominate the environment. So over a long period of time, you go from molecule to molecule to molecule, becoming ever better adapted to the environment until you get complex collections of molecules like us that are pretty good at being adapted to their surroundings. And so you've got, on the one hand, entropy driving us toward ever greater disorder. You've got evolution by natural selection allowing complex structures organized to exist. And so these two forces play off of each other as the universe unfolds.
And yet, even with the existence of these, I don't know if the word is anomalous, organized structures that evolution creates, entropy still increases?
That's right. So you might say, does evolution violate
Right.
the second law of thermodynamics? Does the formation of an orderly structure like a human being, or to be simpler, a star or a planet, does that somehow violate the drive toward ever greater disorder? And the answer is actually no. And it's a beautiful fact because take a star, a really good example. A star forms from a lot of gas that falls in on itself because of the gravitational pull of each molecule of gas on every other. Now, as the star is forming, it gives off a great amount of heat and light in the process. That heat and light streams outward, carrying away a whole lot of disorder, a whole lot of entropy. So even though the star is a pocket of order, if you take into account the entirety of the environment that the star's formation influences, there's more disorder ejected to the wider world than there is order that's formed. So overall, entropy goes up, even though you're left with a beautiful ordered star.
Again, with the Lego, my kids can make a Lego castle, but there are pieces all over the carpet because they had to root through everything to make something with order.
They'd even go a little bit further. So let's say they were to use up all those pieces on the carpet.
Okay.
Where then would you get the extra entropy from? As
It would
they
be
were,
from when I step on them and scream in pain. Sorry, go
Yes,
ahead.
that's certainly part of it. You have to take that contribution too. But as your kids are putting the Lego pieces in, they're burning up energy. They are giving off sweat and disturbing the molecular environment around them. And if you take into account all of that, there's more disorder being generated than order formed.
You even talk about consciousness as the act of thinking you call environmental waste.
Yes.
That, I mean, sometimes we meet people and we're like, I get it. The way that person is thinking feels like environmental waste, let's compost. But consciousness, you say that at some point, our capacity for thought will be part of what burns ourselves out.
Yeah, because if you go back...
That's just for really smart people like you.
Well, you asked a question earlier in terms of how long could we last?
Yeah.
And as I said, it's a little hard to give a precise number because of human behavior, but you might ask a related question, which is, in the best of all worlds, if we are maximally smart at not annihilating ourselves and maximally clever about maybe uploading our consciousness into more durable structures, how long could we last if we're able to do all of that? And that's a question that we can address. Because if you take into account that the act of thinking is itself a physical process, I mean, you can question that, but I'm pretty confident that that's the case, that the act of thinking is just a physical process taking place inside of our heads. It, too, is subject to the second law of thermodynamics, which means every time you have a thought, you are emitting waste to the environment. Now, here's the...
What's the waste made of?
The waste is heat. That's the most basic form of entropy, the random motion of particles created because you've heated up the system. And if you take into account that in roughly 10 to the 50 years from now, it's a long time, right? We're 10 to the 10 years from the Big Bang.
Okay.
But stay with me. If you go 10 to the 50 years into the future, you can calculate what the environment will be like. And you can show that the environment will not be able to absorb any more waste heat at that point.
Like not one bit.
That's right.
One thought could break the camel's back.
So one more thought, and the heat will not be able to disperse outward, and so you will burn up, you will fry in the process of trying to think.
Oh my gosh.
And so that's the point when even thought itself will draw to an end.
So you already mentioned there are. I feel like in this book you kind of explicate just about everything. I mean, Big Bang. He talks about Mick Jagger as legendary if he's considered through the lens of sexual selection, right? He's part of our evolution. But you are swift and unapologetic to name at least two great mysteries that scientists like you have not solved. One, you mentioned we know what the materials of the Big Bang were. We, and when I say we, I mean you, know when the Big Bang happened, nobody knows how the materials got there.
Yeah.
How something was out of nothing.
Right.
Right?
Yeah.
And it's a who, what, where'd they come from?
Yeah, no, it's all of those are good, deep questions. And I wish I had something insightful to say about it. The best that we can really do at the moment is to note possibilities. So one possibility might be that the Big Bang was the beginning of our realm of reality, but that it wasn't the beginning of everything. So in the question of where did it come from, there may have been a whole prehistory to the Big Bang, which may have involved other Big Bangs, giving rise to other realms. But of course, that just pushes the question a little bit further back. I mean, maybe far, far back, but it still asks us to give an explanation of how whatever preceded the Big Bang got started. And so we don't have an answer to that. The other possibility is somewhat more conservative, which is to imagine that there is no before the Big Bang, that time itself starts with the Big Bang. You know, a good analogy is, you know, if you were to try to walk north on planet Earth and you pass by someone and you ask them which way is north, they point you, you keep on going, you pass by somebody else, they continue to point you. But when you get to the North Pole and you say to somebody there, how do I go further north than the North Pole? They say, we don't really know what that means. North begins at the North Pole. You can't go further north than the North Pole. It's a meaningless question. It may be the same thing with time. Go back 100, 1,000, 1 billion years, go right back to the Big Bang, and the notion of going further back may be as meaningless as going further north than the North Pole. So it could have all started then, but still I have no insight into why there is something rather than nothing, right? That's the most basic fundamental question. And by nothing, I don't mean empty space. I mean truly nothing. No space, no time, no energy, no quantum fields, no nothing. Why is it not like that?
The other, I mean, I'm sure there are mysteries that you articulate that I'm not remembering, but the other big one is consciousness, right? So many of you know that Brian very famously said to Stephen Colbert that we are all bags of particles, and that went really well.
He said that's a great pickup line, which I thought was
yeah,
and it is actually.
You should try it. Wish I were still dating, but we don't know. So these are particles, right? This is particles. You and I are particles. We're all made up of the same stuff, and you and I have consciousness, and this table doesn't, and we don't know why, right?
We don't know why. Now, there are some things that you can say about that question. Clearly, there's a difference between you and the table. There are many ways of framing the differences, but for this question, the most important one is you have a certain molecular organization that the table does not have. And that allows you to respond to the environment in a wealth of ways that the table can't. And among the things that you can do is you can take in sensory information from the external world and process it inside your head in a way that the table cannot. Now, it may be that consciousness is nothing but the flow of particles and the information that they carry within a sufficiently organized, coherent, complex structure. In our particular case, that's a 3.3-pound gray, gloppy, corrugated, crenellated object that sits in this bone cave perched on our shoulders, right? I mean, so that is where it happens for us. And it may be that consciousness is simply the result of complex organization and this correct motion of particles. So it may be that we just come to that conclusion. Now, especially in a world where we're headed toward artificial versions of intelligence, if we have sufficient evidence, I would imagine one day talking to artificial systems that they report, Chat GPT 1000 says, I really am depressed. I'm really, Brian, I'm really sad. And I'm not just saying that, I really am feeling it right now. If that really happens, we may, and we're convinced, we may come to the conclusion that consciousness just is the result, an emergent property that comes from sufficiently complex calculations. That may be the answer.
What you are 100% certain of is that consciousness does not provide free will, right? You say there is no free will.
Yeah,
Do all scientists say there's no free will?
No, but they didn't have any choice in their answer. But
you could have predicted that.
Yeah. But yes, I should qualify slightly. Under the assumption, which I'm confident of, but nobody really knows from what we just said, if consciousness is nothing but the result of certain physical processes, then I'm convinced that we don't have free will, that free will is a misleading notion. But if you're of the perspective that, no, you got the physical, but consciousness is something else. It's out there, some consciousness field that's governed by completely different considerations.
Which scientists did think, right, in the 19th century?
Well, what they did was, and it's a really good reference, they didn't think that about consciousness per se, they thought about life.
Vitalism.
So the idea was you can have whatever organization of matter that you want, but it will never be alive until you inject something else from the outside, a life force. Vitalism is exactly the right way of talking about it. But nobody believes that, at least almost nobody believes that any longer, because as we have understood life at the molecular, the biomechanical, and so forth, as we've gone deeper and deeper, the need for something beyond the physical has evaporated. And so, whereas life was so mysterious 100 years ago that we envisioned you needed something else for things to become alive, we no longer feel that way, and I suspect consciousness now feels so incredibly mysterious. I mean, where does this inner world inside of our heads come from? Why don't we just do what we're doing without an inner world taking place behind our eyeballs? You can imagine that could be the way that we are, and yet we are not. So it feels deeply mysterious, but it may be that as we understand it better, as with vitalism, the idea of something from the outside will just go away. That's my expectation. Now, we didn't talk about the free will part, and I'm happy to...
Go for it.
Yeah, so once you get there...
I have to confess, I I would never argue with you about anything. And I wouldn't even argue with you about free will. But there is a part of me, I'll listen, and I'll be like, well, yeah, that sounds right. Of course, I'm sure that's all right. I'm sure all that science is right. And then I will walk out of here thinking, I have free will.
And
what
by
is
the way,
that?
I will too.
You will?
Absolutely. Because you need to describe the world using many levels of analysis, many kinds of stories, right? So right down at the particle level, the electrons, the quarks, the neutrons, and so forth, they, we believe, are fully governed by physical law.
Yeah.
And so if thought is nothing but the motion of particles like that inside of your head, then all of your thought and all of your behavior, right? Like right now, I just seemingly felt like I made the choice to lift up the cup, but what was it?
Are you telling me you didn't?
I didn't. At a molecular level, look inside me as I do this. Really peer inside me, right? It's just the motion of particles in my head, alerting particles in my arm to contract and move. It's just the motion of particles. If you didn't know that I was a living system, you just say, oh, wow, a lot of particles moving, all governed by the laws of physics. I mean, think about it. My particles. It's not like they move according to the laws of physics for a while, and then they say, hang on, guys, stop. Wait for Brian to make a decision. Okay, he's made a decision, keep going. That's not how physics works. The laws are governing all of the time. And so if the laws are governing all the time, then they were governing the decision that I seemingly made. So right down at the particulate level, it seems quite clear to me that the notion of our interceding in their motion is incoherent. But go up to the human level, right? The chemical, the biological, the psychological, the physical. You come to the human level, and like you, I experience a world in which I seem to have free will. What do I view that as? I view that as it's useful, probably from an evolutionary perspective, for us to have the sensation of free will. The sensation is real. We all have it all the time. I feel like I'm in the driver's seat right now. I feel like I'm making the choices and decisions of my next word and action and so forth. The sensations are real, but the fundamental freedom of will to which that sensation seems to point, that is illusory.
It makes me think of kind of what you move into in the second half of the book about how crucial it is in the unfolding of human existence to make up stories, to make up narratives. In a way, the way you just described it is that if none of us has free will, to function as human beings, then it is a fiction. It is a story we tell ourselves that we are in charge of our actions. Yeah. Right? And I want to move into that part of the book. I'm more on the art side, and it speaks to me, right? So I make meaning in my life I actually survive an experience by trying to figure out what it means, by turning it into a story that I can probably tell somebody else. And you are a gifted writer, and you help make meaning by recognizing patterns in the universe, and the way you write them down is not only words, but numbers, right?
Yeah.
Will you talk about how language fits into not only our the way we face our very short time on this earth as humans, but into evolution?
Yeah, I mean, so, as we have tried to survive, a vital part of that echoes exactly what you are describing. We have a need to anchor our experience through some kind of meaning. Presumably, those of our ancestors who had that capacity to invest their experiences with more than just mere survival, but survival for a reason, were the ones that prevailed. And they ceded to us this intrinsic urge to invest experience with meaning. And so what do? We make up. I mean, the universe has no meaning. It's just collections of particles moving under the laws of physics. That's all that there is.
You have this line where you say we want to hug the universe, and it's unrequited.
That's right.
Will never hug us back.
We urge for the universe to give us something more than laws of physics and being collections of particles, but The universe is unable to meet that need. So what do? We make up our own meaning. And how do we make that up? By telling a whole variety of stories. Some of them communicate information to our peers and to the next generation, but some of it we tell in order to feel a greater connection, a greater social connection to those around us, a greater connection to the universe at large. And those stories take a whole variety of forms. And I do consider the laws of physics to be one very particular, very precise story that shows how we are, in a literal sense, connected to the cosmos. But as you go up into the endeavors of human capacity to write novels and plays and to create, it evidences this urge for meaning, and it shows how wonderfully capable we are of inventing tools and techniques for giving us a sense of greater connection.
And you quote Proust, who said, "Only through art can we enter the secret universe of another."
And I think that reflects also to the question that you're asking about language.
Yeah.
So language is only one way of telling stories. It's a powerful way of telling stories because it allows for a certain precision and flexibility in the ideas that we want to communicate. But I think we're all deeply aware that there are ways of knowing the world that are beyond language. Not everybody agrees with that, right? Wittgenstein would not have agreed with that, right? The limits of language are the limits of my world is the approach that he envisioned to be the case, that it's all rooted in language. But I think anyone who's had the experience, which I don't want to get all lofty here, but if you have that sort of transcendent moment, which is not something you articulate in words, and it's not an inner story that you're telling yourself in words, you're just experiencing this thing that's transporting you to someplace else. It's a way of knowing the world that is beyond language, and I believe that's what Proust was referring to.
Yes, it is. I have spent my life getting literal chills when I see a Broadway show, right? And I'm never not grateful for it. I'm like, this is, and I don't have to have words for it. This is what art does to me. I don't know what gives you chills, but.
Well, there are many examples, and to me, it's not only that I don't have words. I'm thankful that I don't have words because I don't want it to be words. When I try to put it into words, I diminish it. It's just the raw experience, which itself is what matters.
Transcendence.
Yes.
So there's a question here, and it leads into a story I want you to tell. So you've just expressed how the arts are a way we deal with the human condition, and of course, religion and spirituality and belief. There's a chapter you have called Brains and Belief, and you write, the evolutionary package deal. The victorious, evolved brain has qualities that embrace religion with open arms. And someone here asks, in your view, how does spirituality fit into the practical understanding we have of ourselves and our place in the universe? Would you please tell the story of walking with your dad and your sister in the late 60s at the, what's it called, the Naumburg Bandshell? That's just right on Poets Walk in Central Park.
Yeah, so, you know, this was the late 60s, although my brother corrects me, it was probably 1970. Okay. So it'll be in the next edition. You know, so my brother's 13 years older than I am, and he left to be a Hare Krishna in the 60s. And I had not seen him in quite some long time. And so my father took my sister and I to what was a Hare Krishna happening at the bandshell there. And I'm looking and I'm like, oh my God, is that my brother? You know, shaved head and playing and singing. And it was quite a moment for me because I had no idea at that point that he had gone into this particular faith. And so it was my father's way of, I don't know, gently taking us to this realization that his life had gone in a different direction than perhaps we had anticipated.
And you write about how you talk about your brother's Vedic search for stability. You have a healthy respect for religion in this book, that why people need it, right? Or spirituality, in your words. And you write about your his Vedic search for stability is akin to the lure you found studying fundamental physics.
Yeah, again, I really do see spiritual and religious practice as one of the other stories that we tell. And again, that's in no way meant to diminish any of these particular undertakings and perspectives and beliefs, but rather I do see, as I said, physics is a story, science is a story. And so as we human beings search for meaning and purpose, there are many ways that we do that. And for some, imagining that there is something beyond the physical is the way that they're able to get to a place of comfort. And my view is, look, we are these little creatures crawling around this nondescript planet that's orbiting this completely ordinary star in the suburbs of a completely ordinary galaxy, which is one of hundreds of billions of galaxies, each of which has hundreds of billions of stars. And now with the James Webb Space Telescope, we're learning that basically all of those stars have planets. So we're talking about hundreds of billions of planets out there, right? And in this immensity of space, who wouldn't be anxious? Right? Who wouldn't have some need for something beyond the everyday to try to give us a sense of stability and connection?
Yeah.
I, in my life, have done that through physics and through trying to understand the deep physical structure of things and connecting it to things of the everyday, but many others go in different directions. And I respect anything that gives someone that comfort. Again, look, religion has been used in many ways. Not all good by any means. We can go down the trajectory, but everybody knows what I'm referring to. So if your belief system gives you comfort and allows you to live in this utterly absurd reality that we're thrust into, that's a fantastic thing and should be respected.
There's no way to absorb this book without constantly referring to one's own entropic existence, right? The macro can always be boiled down to the micro as we read this. And my experience now, having read this twice, is that this book drips with poignancy. This book is so poignant to me. And I wonder, of all your books, was this the most emotional? Because you share very, very beautiful personal stories.
Yeah, no, absolutely. I mean, string theory is emotional. So elegant. But you're absolutely. There's no comparison. I mean, every other book that I wrote was ultimately about trying to explain some deep part of science, right? That's really what it was all about.
Thank you.
And this book was not so much about explaining the science as to explaining how it is that we human beings, how do we fit into this grand cosmological story, and how do we make sense of it, and how do we cope with it, and what will be in the far future. And yes, there were certainly, for me, dark moments when I was writing this book, as I came to terms with things that I've been thinking about for decades. Ultimately, I came out of the experience with a very positive perspective. I didn't, look, when we talk about the far future and we learn that stars disintegrate and planets disintegrate and galaxies disintegrate and black holes disintegrate into a spray of particles that will waft through the darkness, that far future can feel bleak, right? And it's so bleak, you can imagine that, on your darkest day, however bleak and insignificant you might feel, thinking about this kind of far future, makes you even more bleak and insignificant, right? I mean, that's certainly one way that you can come out of this, but my view is quite the reverse. My view is, Nabokov said that we humans are a brief crack of light between two eternities of darkness. Now, he was really talking about the individual. There's a period before you're born, a period after you die, and as you live, that's that brief crack of light, right? But it's true of the cosmos more generally, right? Humanity and life and consciousness is a brief crack of light.
We're like a sliver.
Between two eternities of darkness. And so, my view is that's true, but how fortunate and spectacular it is that we get to participate in that. How unlikely is it that particles happen to coalesce into a structure called Faith and a structure called Brian. The odds against it are immense, and yet we are here. And so the view is, if you recognize how improbable it is that we are here, and on top of that you recognize how amazing is it that a collection of particles can think and feel and love and hate and imagine and create and build the pyramids and construct the Great Wall, prove the Pythagorean theorem, build rocket ships, go to the moon, look back to a fraction of a second after the beginning. Wow, right?
Yeah.
That we can do that.
Yeah.
And so when you focus on that brief crack of light as the place where you invest meaning, you can come out, I think, in a very positive outlook.
I have to share my own recent, it's called Naumburg Bandshell, right?
Yeah.
You all know where it is, right? Right at the Poets Walk. It makes me think of someone fully celebrating his humanity. Just a couple days ago, I was walking by after dropping my daughter off at school. I walked through Central Park. It's like 8:15 in the morning. Some dude is in the bandshell all by himself singing The Impossible Dream at the top of his lungs. And he started like 52 keys too high. So and it's New York, so everybody's just walking by, and then there are people doing Tai Chi over there. But I stop and I film it, and when he gets to this note that he cannot reach, it's that line, to reach the impossible star, and he stops and he goes, "Fuck yeah!" And I was like, that's New York. And that is a man who was looking at his finite existence in the face, and he's like, I'm gonna reach that unreachable star. God, you gotta love New York. This is part of, this tags on to what you just said. Someone wants to know, how do you deal with your impermanence? And that leads to another question I wanted to ask you, which is, what do you want your legacy to be?
Well, I don't think it's about legacy. I think there was a time, I think, when I bought in to that cultural perspective that it's all about leaving something, a trace for the future. But when you realize that, cosmologically speaking, every trace evaporates, is that really what we should focus upon? And so again, it's really a focus more on the everyday. Look, this is not a new idea that we should focus on the here and the now, but for me, getting to it through this cosmological journey emphasizes it in a way that previously never had a pull on me, the way that it does in this setup. So it really is not about trying to leave a legacy. It's about trying to live fully, to trying to actualize and family and relationship in the here and now is where the footprint is.
Before we close, I wanted to share something, which is that, as I said, I read this book first 3 years ago, and then when I knew I was going to talk to you again, I picked it up, and I'm flipping through, and I found on page 163, I had apparently 3 years ago just stuck in this Post-it that my daughter, who was then 5 and is now about to be 9, wrote, and it just says, "Thank you, I love you so much." And just seeing how her handwriting has changed, like now this is, she scrawled this out and she got it right. Now she does cursive and she writes Mandarin characters, but she still says that to me. And you look the same as you did 3 years ago. Obviously, I look the same as I did 3 years ago. But our kids, right? Our kids are the ones that grow so fast, that remind us how time has changed. And if there's anything that can stop time, even for a nanosecond, it's what you said. It's this memory of how precious our lives are and how miraculous it is that we're here.
Yeah, without a doubt.
You write, I just want to close with your own words. You write, this is in the last chapter, "We are ephemeral, we are evanescent, yet our moment is rare and extraordinary, a recognition that allows us to make life's impermanence and the scarcity of self-reflective awareness the basis for value, and a foundation of gratitude. And this moment is rare, and you are extraordinary. And we are all so grateful for your work and your generosity of spirit. Thank you, Brian.
Thank you. Thank you.